Sir, thank you for your patience. Dear participants, thank you for your patience. Sir will be continuing the session.
Sorry for the disturbance, participants. It's a technical issue. Yeah, now we can continue the section here. You know that quantum computing is not confined to a particular field. It is confined to the various technological issues in the entire thing there here. For example, we can apply to the medical field, we can apply to the climate field there here, we can apply to the material science, computer science, biological stuff. In all the things, the data is going to process using a easy and efficient computational techniques such as the quantum computing there here. So in nutshell, we can conclude that quantum computing is developed based on the quantum theory as well as the quantum principles there here. In overall, the entire quantum computing is going to govern, or we can say the rule by the four important the principles. We can say the superposition, meaning quantum superposition, quantum entanglement, quantum uncertainty principle, and coherence there here. Here, each and every principle has its own significance for the development of the quantum computing there here. Yeah, so here superposition is the one of the important characteristic property to understand the multiple states of the qubits there here. We are going to use the new technology in quantum computing, which is qubits there here. We are going to discuss in detail about any further slides there. Here, these qubits are going to exist in a single time in a multiple states, which is not possible for in a classical system. And this information is going to develop a very vast technological applications that here. The second one is entanglement, which is the key principle for the development of the quantum computing area. Here, the two qubits are going to be interact with each other, and as a result, they are going to change their states also too. This is very important concerning to the communications fields as well as the computation fields also too. The last one is the uncertainty principle, where Heisenberg uncertainty principle is going to rule, and it is going to help us to determine the states of the qubits, such as both the momentum as well as the position of the particle cannot be determined in a single time with a more accuracy there. Based on that one, the states of the qubits are going to be determined. The last one is the coherence as well as the decoherence. These two properties are going to, we can say, that govern the remaining three parameters. The superposition is going to give the end result and end, the property of the property in quantum computing, which is going to govern by the coherence property there. Yeah, for the in the development of the total quantum computing, so basically 7 important key components are going to be we need to consider here. The first one is mathematical tools, and because the mathematics is the key language for any technology there. The next, qubit technology, quantum gates, quantum circuits, quantum measurements, as well as quantum hardwares. These are the main key components for the development of the quantum computing. So when you come across, go through all the mathematical tools, the famous scientist Pauli as well as Fermi, they developed the enormous mathematical tools for the representation of the quantum mechanics as well as quantum principles. So we must have a thorough knowledge in these mathematical tools to understand the quantum computation tools that here. So like complex numbers, matrices, linear vector spaces, and polynomials, basically for the higher order polynomials. And in quantum mechanics, it gives the entire the probabilistic value there. There is no certain value there here. So we need the statistics to understand about the eigenvalues, eigenstates, to represent the state of the qubits there here. And also we need the operators. In Hermitian operators, we need there. In quantum mechanics, basically, to represent the state of the particle or state of the qubit, we need a wave function. That wave function is going to governed by the wave properties as well as the particle properties there here. And these properties are going to represent by the Hermitian operators. Means if you want to understand any property of any particle or a state, the position, momentum, energy, or any other parameters, we need to apply.
This one.
So this one, sir. Okay.
This one.
Yeah, this one, sir.
This one.
Yeah. Still, right. So I'm sorry for the disturbance, dear participants. The functions there here. So this allows the quantum computers to process the large amount of information in a parallel manner. It is not possible in case of a classical computations like here. In a classical computation, each and every task is going to calculated or processed by in a single time in a particular track. But in quantum computing, all the problems in a different tracks at a time we can run and we can compute the computations there here. This is known as a parallel computation. Moreover, to develop these qubits, different technologies we have adapted, like a ion swapping technology, photonic technology, superconducting technology, which is the most famous there here. And their manipulation is also very important in quantum computation. By using the laser technology, we are going to change, we are going to manipulate the states of the qubit so that we can develop the circuits as well as algorithms also to them. So here, the main thing is the entanglement. The ability of the entanglement with the other qubits supports the correlation so that it's going to boost up the quantum computations to solve the very complex problems in comparison to the classical computers there. So next we are going to discuss about the quantum gates. We know that these quantum gates are the building blocks for the development of the quantum circuits. These are similar to the just like a logic gates or classical gates they here. But these quantum gates are going to manipulate by the laser technology so that the states of the qubits by applying the certain quantum operations like flipping the states or creating the superposition or generating the entanglement, we can boost up the correlations to solve the complex problems there. Unlike these classical gates, like these quantum gates have the capability to solve the complex problems because they are going to express in complex amplitudes, which is going to make a drastic difference in comparison to the classical one. So make it is possible to transform the quantum states there. Generally, in previous sections, you might have heard so many quantum gates are there. So main important quantum gates are here, the NOT gate as well as the C0 gate. There here, NOT gate is going to promote the superposition and C0 gate is going to promote the entanglement there. So now we are going to discuss a brief discussion about the quantum circuits. These quantum circuits are like a building blocks for the generation of the entire quantum computing techniques there here. These are the sequential developments of the by using the quantum gates there here. First, we use the quantum gates Next, we just generate the quantum circuits, and next we are going to generate the quantum algorithms. By using these quantum algorithms, the complex quantum circuits are going to follow the sequential procedure to solve the problems as well as optimization like here. In the process of the optimization, these quantum circuits are the key parameters to solve the issue here. Means here we are going to follow a sequential procedure to solve the complex problems by involving these quantum circuits. Here I'm not going to take much more. I'm saying that this quantum circuit is one of the key component to understand about the quantum computing. So this is the measure. So when you just compare all the things to extract the information from the quantum gates as well as the quantum circuits by following the quantum algorithms and also followed by the quantum computing processing units there, we need to perform the quantum measurements to extract the output there here. So this is the key component to get the information. Here, the output is going to convert into the classical outcomes. So this is very important. So when you do the quantum measurements, it is going to refer to the process of extracting the information from the qubits by collapsing its quantum states. This is very important. And it is going to convert into the quantum outcomes. Moreover, in advanced measurements techniques, these guarantee extraction of the results and allowing the quantum computer to solve is a very big challenge in that. And quantum hardware is one of the key component for the development of the hardware here. As I mentioned previously, we are going to use the different technologies for the development of the qubits, such as ion trapping, superconducting, as well as we are going to use the laser technologies also too there here. But however, the maintaining the qubits in a stable quantum state is required, many hardware requires there here. So this quantum hardware requires, like if you consider for superconducting, quantum hardwares, we need to maintain the temperature, controlling the temperature, reducing the noises, environmental stability. All these are going to influence the outcome of the quantum computing results there here, such as ultra cold temperatures and isolation of the entire experimental chamber from the external inputs. So these things are very difficult to maintain the quantum hardware. However, we need these things to run these quantum computing computational techniques there. So to understand about this quantum computing, different kind of software tools have developed and also platforms are existing now here. So IBM just developed the Qiskit, and this one Google is also developed the SRIC, and so many different companies are developed their own tools to understand about this quantum computing as well as processing this complex computational techniques there. This slide is going to give the different software tools which are developed by the different, I can say, the giant companies, the companies in quantum computing there here. Yeah, now we are going to focus on the main topic here. So what is the future of this quantum computing? So now I have given a brief introduction for what is the quantum computing, what are the main key components to understand about the key quantum computing here. These topics have Dave and explained in detail about the previous sections there here. Now we are going to focus on the quantum computing here. And there is no doubt at all that the remaining future is flourishing and everything is going to be computing are governed by this quantum computing there here. Here, two types of things are there. Large scale quantum computing is there, and the academic level of, small scale quantum computing are there. So actually, the large scale quantum computings are still under the research, and they are not up to the mark in the industrial level. But when you come to the small scale computing, quantum computing, the technologies, they are already implemented in academic and in some of the industries, and some of the private companies are going to use, like IBM, Google, Microsoft, and this Amazon. They are going to use these small scale quantum computing techniques to solve the complex issues in their business as well as in finance, is in the logistics also too there. So now the main important thing that the researchers are going to focus on reducing about this quantum coherence effects as well as the noise effects. These are going to mitigate the effects of this quantum computing there here, so that still the research is going on to develop the large-scale quantum computers at industrial level. Therefore, the governments also are focusing on different academic as well as industrial and eminent persons to give the awareness to the students as well as for all the members in the society for the development of the quantum computing and reach the high level there. In India, the National Quantum Commission is also there here, which is encouraging to all the institutes, higher education institutions to give the awareness to the B.Tech students as well as the M.Tech students to increase the human resource for the development of the quantum computing techniques as well as resource persons from India there to solve all the technical issues there. So the future is flourishing regarding the quantum computing and remaining all the techniques also going to be governed by this quantum computing there. So here basically recently some advancements in India we just observed there and reported from the Niti Aayog also too. From the Indian scientists as well researchers, they gained, we can say that they published very good papers on these components. They succeeded to overcome all these technical issues, which I just mentioned this slide here. I mean, the longer qubit coherence, this is very important for core component for the quantum stability there here. And also we come across the one of the important technical trouble, we can say that mitigate the things there here, which is enhanced qubit control and fidelity. And this is really a drastic change, and it is going to help us for enabling the more accurate operations when you are doing the parallel operations right here. Moreover, the error correction progress is one of the important achievement from the Indian side that here this is going to pave the way for the towards the fault tolerant quantum computing. This is a recent technology which we are going to use in finance. The next we are going to use the multi-horse race there. Means in parallel computing, we are going to run the different computations in a single time so that we can estimate or we can understand the things in an easy manner, which is not going to possible in case of a classical computation techniques, and which is going to give the information about the diversity of the qubit modalities. So it is a continuous process, so that continued pursuit of the topological qubits, and this is a potential game changer because last time in the previous slide I mentioned that when you develop the quantum qubits technology, the noise is very important, and also environmental effects on the qubits also very important there. But when you develop these topological qubits, these are absolutely robust. They are going to be sustained. They are going to face, even though there are some outside problems or the noise problems or their environmental problems or there, these topological qubits are robust and they are going to sustain. So these topological qubits are going to change a drastic change in further future quantum advancements there. And last one is the software and algorithms innovations. So new algorithms are there implemented to continue to solve the complex problems as well as unlock the quantum potential problems by using this quantum computing. So this slide is going to be a very important thing there here because whenever you just observe the 10 years of experience, the investment, how these countries are going to show interest on the quantum computing there, every year the investment from these countries are going to gradually increase in there here. Now you are 2024, if you observe here, there are almost some thousand lakhs of the dollars that they are investing there here. Means finance section, logistics section, research section, medical section, as well as clinical sections, they are going to investing much more amount on this quantum computing to understand the data computations so that we can minimize the problems in the society and we are going to provide the better society for the human resources there. So the main thing, this quantum computing is going to show the impact, substantially impact on many sectors. But so I'm going to focus on a few important things I have chosen here. So the impact of this quantum computing advancements on our daily life is very important, of course. So the whatever the technology it may be, it has to be helpful for the human persons there in the society there. That is the end product, right? So here, how these quantum computing advancements are going to show the impact on our daily life. So first thing is that when you come to the academic section, it is artificial intelligence and machine learning. This is one of the drastic development you can observe there, cryptography and data security. drug discovery and development, the disease risk predictions, financial modeling and portfolio optimizations, and traffic optimization in smart cities, and weather forecasting, as well as the climate modeling, grid optimization in case of energy storage here, material science developing. So likewise, so many spectrum of fields you can mention in which the quantum computing is going to show the substantial impact on these fields that here. However, I'm not going to touch all these things here. I have chosen few things within the short time to explain about how the quantum computing is going to show the impact on our daily life here. And basically, the national security is very, very important. In concerning to the national security, how this quantum computing is going to help us to increase the security in all the concerns, like a cyber security, or it may be the national security, or it may be the war security. So all these things are going to be easily developed by this quantum computing to overcome many technical issues which are cannot be solved by the ordinary classical computers like here. Yeah, when you come to the artificial intelligence and machine learning, so dear participants, there is one important thing is that here, collecting the data is the one edge, and second is that handling the data is a second edge. So when you have this quantum computing as well as machine learning process there here, this quantum computing has the capability to handle high dimensional data there. This is very important there here. So by handling the data in a very easy manner, by following the machine learning process, we can compute all the problems in a single time in a parallel way here, so that we can commute all the output of the problems that here, and we can come to a conclusion with the easy answer that here, means easy solution to the problems there. So this is one of the impact of this quantum computing on machine learning there here. And so many models are going to develop based on the machine learning. And recently, one of the research paper is just published on this one that is going to state that the ability of this machine learning process is going to be open a big room for the multiple possible solutions for the simultaneously to solve the many issues there here. This could help the researchers to identify patterns in which the large data sets that might otherwise be computationally prohibited to discover in a new methodologies or new ways to solve the issues that here. The last thing is that we can say the artificial intelligence. Still, this field is in a progressive, and we can say that it's a research level, means how the quantum computing is going to show the artificial intelligence. There is no doubt at all in combining with this artificial intelligence and quantum computing, any complex problem is going to solve within a very easy manner there. So this is one of the impact on the society, because we need the drug development for many diseases there here, and the pandemic situations we already faced there. Now the many industries, clinical industries and the gigantic medical field investments, they are encouraging the researchers in quantum computing to do the research on the drug discovery as well as the development. So here the main thing is that how a small ligand is going to interact with the protein and what kind of interactions